Hey everybody, this is Mr. McKinney again, and we are back with our moles review continued. Today, we are focusing on molarity. Molarity is probably one of the most used units, one of the most used topics within AP Chemistry. So molarity, if you understand nothing else from this week, I hope that you spend a little extra time learning molarity. Well, what is molarity? Well, molarity is a measurement of the concentration of a solution. So, and when I say concentration, what does that mean? That means how much solute is inside of the solvent. So you could have a very strong concentration or a very weak concentration. We would say that a weak concentration would be something that is dilute or diluted. So if a molarity is a high value, then it's going to have a high concentration. If it's a low value, it's going to have a low concentration. It's going to be more dilute. So how do we solve for molarity? Molarity, or what's the formula? Molarity equals moles over liters. So moles over liters. So in order to find the molarity of something, you need to know the moles, you need to know the volume. So and the volume is always in liters when we're finding molarity. So a molarity would be represented like, it would look something like this, capital M, so 0.5 molar salt solution. And remember, when it's a solution, we would do aqueous. Okay. All right, so remember the AQ next to the formula means aqueous, means it's dissolved in water, so it's a solution. So you would say it's a 0.5 molar sodium chloride solution. That's how you would say that. And the capital M stands for molarity. So how would you go about solving things, or what kinds of problems might you see? So one thing that you must know is this is a 3-variable equation, right? So in order to solve for anything, you have to know 2 of the other variables. So in order to solve for moles, you need to know the volume and the molarity. In order to solve for volume, you need the moles and the molarity. In order to solve for molarity, you need moles and the volume. So in a problem, you might be given something like this. How many moles are in a solution, are in a 2.5 molar solution in a sample of 500 milliliters? Okay. So in this case, if you're given the molarity and the volume, and this is going to be pretty common in this course. You're given the molarity, the volume, you need to solve for moles. And even on the AP test, a lot of times you'll get a point when you're solving for moles on the free response questions. So how would you go about doing this? Well, if I know liters and I know molarity, moles over liters. If I rearrange this equation, I want to get moles by themselves to solve for it. I simply multiply both sides by liters. Liters cancels, so then moles will give me liters times molarity. Okay, so if I know my molarity, which is 2.5, and I know my volume is 500 milliliters, I need to convert that to liters, right? How do I convert milliliters to liters? There are 1,000 milliliters in a liter, so I simply move the decimal point over 3 times to the left. So this would be 0.5 liters. So I do 0.5 times 2.5, and basically half of 2.5, which would give me 1.25 moles. And that would be my answer. Okay. Again, I need to convert that. That becomes 0.5 liters. Okay. And you will have to do that quite often, change the milliliters to liters, because most of the time in chemistry we're going to measure our volumes in milliliters and not liters, just because we're working with smaller quantities than liters. So a lot of times you'll be given it in milliliters, you'll have to convert it to liters. Okay. So how would it look if you're trying to go from, let's say we have we place 5 moles, let's say 5.0 moles of some salt in 250 milliliters of water. And I want to know what's the molarity, right? Well, I know moles and I know volume. So if I go back up to I know volume and moles, I'm solving for molarity. So I'm just simply going to divide those two. Okay, so I'm going to do 5 moles, molarity equals 5 moles over, and this is 250 milliliters, which again, if I convert that 250 milliliters, move the decimal point over 3 places, 1, 2, 3, becomes 0.250 liters. So I'm going to put 0.250 liters on the bottom. So now I'm going to do my math. 5 divided by 0.25. I can't do that in my head too easily. I probably should be able to. That's going to be 20. So that'd be 20 molarity, a 20 molar solution, which would be very, very, very concentrated. Okay. Now, another thing we could do is it might ask in a question like the one we did at the beginning, the first question we did, it might ask us for grams. So, how many grams of solute, whatever it is, were placed in the solution if the solution is, let's say, 3.2 molarity and it has a volume of 300 milliliters. So if I'm looking for grams, I know I can't go straight from these two to grams, but I do know that I can go straight from these two to moles using my molarity equals moles over liter formula, right? So I can definitely solve for moles. And then once I have moles, what can I do? I can convert it to grams using the molar mass. So the first thing I would do is first convert it to moles. When in doubt, mole it out. That's kind of the AP Chemistry, an AP Chemistry motto. When in doubt, mole it out. So if all else fails, solve for moles, okay? And since I know I have molarity and volume, I know I can solve for moles. So moles equals molarity times volume. And again, I'm going to convert the milliliters to liters, which again is just moving the decimal point over 3 times. So I get 3.2 times 0.3, which is 0.96. 0.96 moles. Now, once I have moles, I need to convert that to grams. Well, I didn't give you a, let's make up a compound, or I'll give you a compound. Let's say it's potassium chloride. Okay. So what I would need to do, I need to convert this to grams of potassium chloride. Well, what do I have to do first? I hope you said find the molar mass. So K, molar mass is 39.1. Cl is 35.5, so 6, that's 14, so 74.6. Okay, so, and that's grams per mole. So now I'm going to take my moles, I'm going to set up a T-chart like I did before, okay, where this is 1 mole KCl, and then on top is going to be 74.6 grams KCl. And then from there I'm simply going to multiply the top and multiply the bottom and divide. But again, the bottom is just 1, so it doesn't really matter. And I would get 71.6 grams KCl. So what does that mean? What does that number tell us? That number tells us that I added 71.6 grams of KCl to 300 milliliters of water, and that got me a 3.2 molar solution. That's how concentrated it was. So if I would have added less than 71.6, this number would have gone down, right? If I would have added more, this number would have gone up. But I added this much, so that's my concentration in 300 milliliters of water. Okay? Hopefully this makes sense. I will see you guys next time. Thanks for watching.